So in this video, we're going to learn how to make an electromagnet. We're going to talk about the supplies that we need, and more importantly, how do those supplies work together to create a strong electromagnet. So first of all, there's three supplies that we need. We need conductive wire, we need a metal rod, which in this case is a nail, and we need an electricity source, or in this case a battery. Now each one of these has special properties, but first let me tell you how to construct the electromagnet, and then we'll talk about the special properties of each. First, we take the conductive wire and we wrap it around or loop it around the iron nail. And as I'm looping it, you'll know, you may already know this, or one thing that you can know is that the more loops I have, the stronger the electromagnet will be. So I'm trying to put multiple loops on here. Now, as I finish creating this, I want to demonstrate first of all that this nail is not already magnetized. And so I have these two paper clips. These are metal, they're attracted to magnets. I'm gonna put this nail up to the paper clips, and notice that it does not pick it up. So this is where the electricity comes in, or the electro in our electromagnet. So I've got these wound around, and now I'm gonna connect each end of the battery to one of the ends of the wire. At this point, electricity has begun to flow through the wire and the wire surrounding the nail. Now if I place that same nail up to the paper clips, it can pick up the paper clips. This isn't a very strong electromagnet. To make it stronger, I should do more loops, perhaps get a stronger battery, but it's able to pick up those paper clips. So, what is so important about each one of these materials that we need? First of all, let's talk about the electricity. All electricity has a special property, and that is that electricity produces a magnetic field. However, the magnetic field in the wire by itself is not strong enough to pick up the paper clips. So, I had to try to figure out a way to strengthen that magnetic field. Well, the electricity flows through this wire, and the reason why it flows through the wire is because the wire also has a special property. It has free electrons. Now, free electrons allow the movement of electrons from one atom to another. And so whenever the electricity is going through the wire, basically electricity is just the movement of electrons. So the electricity is flowing through the wire. Well, if I have all of these coils wrapped around this rod, that means that the magnetic field is just continually looping around this metal rod. Now this metal rod, it also has a special property. Inside this metal are little mini magnets that we're going to call domains. And whenever the domains are not lined up, it doesn't make for a very strong electromagnet. So right now I can't pick up these paper clips again because the domains are not lined up. However, if I line up all these domains so that they're all pointing the same direction, all the north pole is going this side and the south pole is going to this side, it will strengthen the magnetic field and allow me to pick them up. And so I'm going to connect this battery one more time. I've added a few more loops, so hopefully it'll be a little bit stronger. And now I can pick up my paper clips again. And so just a quick summation of what we've talked about. We need three materials. We need an electricity source, a conductive wire, and a metal rod. Each one of those things have a special property that contribute to the electromagnet. First of all, the electricity has a magnetic field whenever it's flowing. The electricity flows through this conductive wire because it has free electrons that allow electrons to move, which is electricity. And the metal rod has domains in it that whenever they line up, they help create a strong electromagnet. As soon as I take the electricity source off, the domains stop aligning, and I can no longer pick up these paper clips.